am Dr. Balakrishna K, working as an assistant professor in Department of Electronics and Communication at Maharaja Institute of Technology, Mysore. In our previous class, we were discussing about the Module 5 in the course Fiber Optic Networks, that is the optical network. Right now, we are studying about the public telecommunication network overview. Normally, we will be knowing that is what is telecommunication and what is the network. But here we are dealing with respect to public telecommunication network. What is this telecommunication network? Normally, telecommunication network will be providing a services. If that services are preferably giving with respect to a public, we will be calling it as an public telecommunication network. So, if you consider with respect to a public telecommunication network, that whatever the communication we are giving as a service, that service can be in a terms of a variety. So, based on this service, that is variety of services, we are differentiating this particular public telecommunication network overview with respect to three groups. What are those three groups? See, out of these three groups, the first one will be considered as a long haul network. This will be the first one, long haul network, and the second one will be the Metropolitan network, and the third one will be the access network. These are all the three different groups with respect to public telecommunication network. All these are a network connectivity. So, what is this particular long haul network, Metropolitan network and a access network? Let's see one by one. First, I will go with respect to a long haul network. See, if you consider with respect to a long haul, where this long haul network can also be called as a broad network, that is broadcast network. See, if you consider with respect to an broadcast network, I will be writing a platform. Let's consider it as a platform. Platform is nothing but that is area covering with respect to a long haul network, where the area that will be covering with respect to a long haul network, that will be in a terms of an hundreds kilometers to an thousands kilometers. So, I will be writing the kilometers covering will be in terms of hundreds to thousands of kilometer, that will be covering with respect to a long haul network, where here for the communication purpose, the data can be of any type, that is it can be a voice, data, or it can also be in video. The information can be of any type. So, for a make a connectivity with respect to one-to-one, we are using an optical cross connect. Here we are using an optical cross connect, where I will be representing the optical cross connect with respect to an OXC. This is also an optical cross connect, where these are connected with respect to like this. See here, the networks are communicated with respect to connectivity of a network. That network will be connected in terms of an optical cross connect. That means here the connectivity will be working based on the switching mode operation. We already learned how the optical cross connect will be working in our previous class. So, here it will be operating with respect to an switching operation, where this communication can be happen with respect to an nationally as well as an internationally, where we can connect from one country to another country. If you consider we are in India, we can communicate with respect to Australia, US and Japan, and similarly for other countries. If you want to make a connectivity with respect to other countries, we need to have a connectivity with respect to long haul network. In some cases, if the distance are far away, let's take an example, we are in Karnataka and we want to make a communicate with respect to Delhi. Another person will be sitting at a Delhi. We need to make a communicate with respect to a person sitting at Delhi. So, at that condition, we need to use a long haul network because the distance will be in terms of 2000 kilometers from Karnataka to Delhi. It will be 2000 plus. So in that cases, we need to adapt this particular network, that is a long haul network, where we can also call it as a broadcast network. And the next one, if you consider with respect to the next one, that will be considered as a Metropolitan network. So before going with respect to the Metropolitan network, we will be having a connectivity, so that will be considered as an OE. So this will be considered as an Metropolitan network. So to represent the Metropolitan network, I can represent this Metropolitan network as well as Metro by the name Metro or MAN. What is that MAN? Because the MAN will be considered as a Metropolitan area network here. So if you consider with respect to the Metropolitan area network, I will be covering the distance in terms of hundreds of kilometers. It will be communicating the information within the hundreds. So the hundreds is not only with respect to within the 100, you can communicate the distance in terms of 100, 200, 300 and also with respect to 400, 500 in terms of hundreds. So to make a communicate with respect to this Metropolitan network area, we are adopting the technology that will be considered as an optical add or drop multiplexing technology. Optical add or drop multiplexing technology. So if you consider that is optical add or drop multiplexing technology, you will be knowing how the optical add or drop multiplexing technology will be operating, because it will be having information, that is multiple number of information will be transmitting, where within that information you can drop the any one of the particular wavelength depending upon the application, and also you can add another wavelength with respect to that information. So finally you will be getting a output depending upon add and drop the wavelength. So similarly we will be using this particular, that is optical add or drop multiplexing technology with respect to Metropolitan area network, where it will be covering the distance with respect to hundreds of kilometers, where this Metropolitan area network will be connecting in terms of a ring topology. We will be connecting with respect to a ring topology. You have to make a connectivity with respect to ring topology, and also you will be knowing what is the advantages and what is the disadvantages with respect to ring topology here. So if any one of this particular will be failed, it will be affecting with respect to another node also. And the last one, if you consider with respect to the last one, we will be having a thing here. So here I will be calling it as an access network. This is the last one. This access network will be working with respect to connectivity less than 20 kilometers or around the 20 kilometer of distances. So if you consider with respect to access network, finally you will be having a users at the end. So here you will be connecting with respect to users. You will be having a n number of users. So if you consider a access network, we will be having local exchange, local office exchange. I will be calling it as an local office exchange. It will be connected with respect to remote node, where in this case you will be connected with respect to some connectivity. So directly this remote node will be connected with respect to the users. This is how your connectivity will be operating. See here, this will be the end users. So depending upon the distance, you need to select whether you will be going to adopt the access network or a metropolitan area network or with respect to long haul network. So how you are going to adapt depending upon the distance. If the distance will be with respect to some kilometer, that is tens of kilometers, you will be adapting the access network, that will be considered as an local network area, that will be having a connectivity with respect to around yourself. And if the distance are in terms of hundreds of kilometers, again you will be choosing with respect to metropolitan area network, that is MAN. Here, to operate with respect to metropolitan area network, you have to go with respect to technology that will be considered as an optical add or drop multiplexing technology. And if the distance is in terms of thousands of kilometers, you have to adopt the long haul network technology here. So long haul network you will be using a technology that will be considered as an optical cross connect technology. So if you are choosing with respect to long haul, you will be having the local exchange, remote node and optical added multiplexing technologies, and also with respect to optical cross connect technology. So if you are using with respect to metropolitan area, you will be having a local office exchange and a remote node, and you will be using a technology that is a optical adder drop multiplexing technology. If you are using with respect to an access network, that is a local area network, you are restricting yourself with respect to local office exchange and a remote node. So if you are going to have a communicate with respect to one node to another node, you have to preferably use this local office exchange as well as the remote node. So depending upon this distance, whether you have to include the optical adder drop multiplexing, it will be decided, and also to include optical adder multiplexing and also optical cross connect, that will be decided depending upon the distance. So this is with respect to the how the public telecommunication network will be operating. Next topic is optical network transmission modes, that is we are dealing with respect to layers and protocols with respect to transmission mode in a optical network. In this particular optical network transmission mode, first we are discussing about the synchronous network. See here we are showing the block diagram, that is nothing but a European multiplexing hierarchy. The first figure will be explaining about the existing synchronous structures with respect to multiplexing hierarchy. The figure B will be explaining about the synchronous multiplexing. See, what is the synchronous network? If you consider with respect to this synchronous network, normally if you consider a synchronous network, we can adapt the different standards with respect to the synchronous network. Normally we will be having a European technologies, North American technologies and a Japan technology, but we are here taking the examples as an European standards, that is for that particular thing we will be calling it as an European multiplexing hierarchy. So if you consider the first figure, in this particular figure we will be explaining the schematic way in which the European hierarchy is multiplexed up to the 140 megabits per second rate for the consisting of 2 megabits per second. So the channel will be varying here. Normally the channel will be having with respect to 30 channel signal. The channel is nothing but a signal here. So that will be considered as a 30 channel signals. So here when you are making with respect to moving from a 2 megabits per second to 140 megabits per second, so the process of multiplexing, you will be having some difficulties arise with respect to these conditions. So how the difficulties can be overcome here? Normally with this multiplexing strategy, which is currently adopted throughout the world in that particular, that is each will be having a 2 megabits per second transmission circuitry. It will be having an independent clock to provide for timing and also with respect to synchronization, because the timing and synchronization will be very important term with respect to making a multiplexing here. If the synchronization is not happened with respect to this communication, the signals cannot be reach the particular node at a particular time here, and also the signals will be overlapping with respect to one with another here. So that will be the one disadvantages if the synchronization has not been happened here. And also here the result will be slightly different, it will be having a different frequencies occurring throughout a network, and it will be for that region we will be calling it as an synchronous transmission. If the particular frequencies are normal and it will be having a constant thing, we will be calling it as a synchronous. If their frequencies are different, we will be calling it as an synchronous here. So the first one will be the synchronous, the figure number A, and the figure number B will be considered as an synchronous. So if you consider with respect to this condition, the presence of bit stuffing with respect to this existing synchronous digital hierarchy. Normally that synchronous digital hierarchy will be also called as an PDH. PDH will be abbreviated as an synchronous digital hierarchy, where this synchronous digital hierarchy makes it virtually impossible to identify and extract an individual channel from within a high bit rate transmission link here. So you have to go with respect to stepwise increasing from a nominal mode to higher level here. And also to obtain an individual channel, the whole demultiplexing procedure through the various levels must be carried out here. So the process in which both complex and also uneconomic, particularly when we are considering with respect to future telecommunication networking requirements. What are the future telecommunication networking requirements? Normally that is drop and insert will be considered as an future telecommunication networking requirements here, where individual channels are extracted or inserted at a particular stages here. If you consider with respect to the stage 1, stage 2, stage 3 here, we will be adding or also we can drop the particular channels here. And moreover, we will be having a substantial saving with respect to electronic hardware in this condition. If you are adopting this technology, the hardware will be also, the cost of the hardware will be also saved in this condition with increased reliability. Moreover, if you are making a design, the reliability will be an important one. Here we are increasing the reliability. So that could be achieved by having a straight say to, that is 2 to 140 megabits per second. So in this condition we can go with respect to multiplexing as well as demultiplexing. If you are going to synchronous, that is with respect to figure number B here. Here we will be showing the STS1 frame structures. Here, what is this STS1 frame structure? Normally this STS1 frame structure will be considered as an basic building block of the SONET signal hierarchy, where it will be having higher level signals with respect to a hierarchy, where these are obtained by byte interleaving. What is this byte interleaving? Normally byte is nothing but a BYT. Byte is it will be having a 8 bits. So in this interleaving, byte interleaving, we are using a appropriate number of STS1 signals, that is similar manner with respect to an European standard, that is PCM standard here. So if you consider with respect to an, normally you will be going with respect to comparing with respect to European and North American hierarchy here. Normally if you consider with respect to an, that is we are restricting ourselves with respect to an European here, European technology. So here the STS1 frame structures will be shown here. It will be having an precisely 125 microsecond and there are 8000 frames per second. It will be a standard. So here these structures enable digital voice signal transport at 64 kilobits per second. So if you consider 64 kilobits per second, what is the bit rate means? Normally 1 byte per 125 microsecond will be happen here. And if you consider with respect to a North American will be considered as an DS1 here, where it will be having an 24 channels, that will be having a bit rate of, that is 1.544 megabits per second. And also if you are considering with respect to European, and if it is restricted with respect to 30 channel, and it will be data rate will be in terms of an 2.048 megabits per second here. So that will be, this all will be accommodated with respect to data rate. So if you consider with respect to other signals, so other signal is nothing but we are going with respect to comparison with respect to each channel. So here channel, if you are considering, before going to this figure, let's consider comparing with respect to, that is STS1 frame structure. So how we are going to compare it with respect to this figure base? It will be having a rows and columns. See here figure, I will be showing the rows and columns here. Normally this will be having a 90 bytes. The complete, the distance of this row will be considered as a 90 bytes, and totally what amount of bytes it will be providing means, that is 90 into 9. So it will be having a 9 rows. See here, vertically we have written the 9 rows, and horizontally we have represented it as a 90 bytes. 9 into 90, it will be taken as an 810 bytes here. So it can provide totally 810 bytes. So that 810 bytes is nothing but, it will be multiplied with respect to 8, because bits per second if you are multiplying, that means 6480 bits per second when you are considering with respect to 125 microsecond, because one frame is nothing but 125 microsecond here. So this results in an 51.840 megabit second, that is a base rate, that will be representing the base rate. So if you consider with respect to this STS1 one frame here, the first 3 bytes, if you consider, it will be having a 3 parallel lines here, that will be considered as 3 bytes. In each row of this particular STS1 frame contain transport overhead bytes. So it will leaving the remaining 783 bytes to be designated as the synchronous payload envelope, that will be considered as an SPE. SPE will be abbreviated as an synchronous payload envelope here. And apart from the first column, that is the first column is nothing but it will be also consisting of a 9 bytes, where which will be used for the path overhead, and the remaining 774 bytes out of this 783 will be minusing the 9 bytes. So finally we will be gathering the 774 bytes in the SPE. So SPE is nothing but a synchronous payload envelope. So this will be constituting the SONET data payload here. SONET is nothing but a synchronous optical network here. That will be the communication protocol with respect to optical communication. And also the transport overhead bytes are utilized for functions. What are those functions? Normally the functions can be happened with respect to transport overload or framing, scrabbling, error monitoring, synchronization and multiplexing. These are all the different functions that can operate with respect to the transport overhead here. Well, the path overhead will be within the, that is SPE, that is a synchronous payload envelope, is used to provide end-to-end communication between the systems carrying the digital voice and also with respect to videos and other signals which are multiplexed with respect to the STS1 signal here. So this is with respect to the STS1 signal here. And next, if you are moving with respect to the STS1, that is with respect to the frame structures. Normally if you are considering with respect to the STS1 frame structures, here we are showing the figure of the STS1 frame structures. Here it will be having a, that is SPE nodes. In this case also, that is STS1, whether it, if we are going with respect to STS1, it will be having SPS1, yes, that is SPE in this condition. But if you are comparing with respect to STS1, STS-N signal frame, normally the format will be in terms of an, that is N signal frame. Here why we are mentioning the N means, here it will be obtained by byte interleaving, that is interleaving will be with respect to, that is N number, that N values can be with respect to any number of values, that is 1, 2, 3, 4, 5, anything. So if you are going with respect to STS1 signals, the interleaving with respect to STS1 signal will be with respect to the N values. For that reason we will be calling it as an STS-N signal here. So in this case, the transport overhead bytes of this particular each STS1, if you consider STS1 means it will be having a 3 single byte columns of each STS1 signal as shown in the previous figure, but here it will be having a frame aligned to create the 3n. Here I will be calling it as an 3n bytes of transport overhead. Previous one we have represented it as an bytes, but in this case it will be 3n bytes it will be considered as an. So here the SPE do not require alignment. So since the service payload pointers within the associated transport overhead bytes provide the location for the appropriate synchronous payload envelope here. So this is the working with respect to this STS-N frame structures. And also if you are comparing with respect to the synchronous digital hierarchy, you can take the examples by comparing with respect to the synchronous digital hierarchy, by comparing with respect to SDH as well as the SONET. So if you are comparing with respect to SDH and a SONET with respect to corresponding levels and a bit rate, you will be having a different standards with respect to them, will be depending upon the line rate. Line rate is nothing but how you are giving the bit rate with respect to this condition. So depending upon that, you will be gathering a different synchronous payload envelope rate and also transport overhead rate here. So this is one with respect to the STS-1 and STS-N frame structures. So the next topic will be the internet protocol. Here we are showing the diagram, that is the internet protocol for the optical network applications. So what is this internet protocol? Normally we'll be calling it as an IP. IP stands for the internet protocol, where it will be also a network layer. Normally the layer 3 protocol with respect to the OSI model. You know that is what is OSI model. You will be having a 7 layers with respect to OSI model. The layer 3 will be considered as an internet protocol here. See, it contains both addressing as well as the control information to enable packets. The packets is nothing but a datagrams to be routed within the network here. So here, if you consider the internet can be categorized as a logical architecture. What is this logical architecture means? Independent of any particular network, that will be considered as a logical architecture, where which can permit multiple different networks to be interconnected, enabling each network node to communicate without the need to know which network it is using or how to route information between them with respect to connecting one network to another network here. So if you consider with respect to this figure, here we are showing the IP. That IP provides the means of communication between the link and the transport layer here. So if you consider virtual connection is established between the nodes requiring a communication when internet protocol is combined with a specific higher level protocol. What are those higher level protocol? Normally that higher level protocol will be called as an transport, it is not transport, it is a transmission control protocol, that is a TCP, or you can also call it as an user datagram protocol, that is a UDP. In a transport layer you will be having a two higher level protocol. The first one will be the transmission control protocol, that will be TCP, and the second one will be the user datagram protocol, that is a UDP. You can use any one of this protocol. So if you consider with respect to this TCP IP, what is the role of this TCP IP here? Since normally you can also call it as an TCP IP will be a standard. Similar fashion you can also call it as an UDP or /IP here. So this does not guarantee reliable delivery of the data in comparison with the TCP or IP. Normally it generally encapsulates data from the link layer protocol. What are those link protocol means? That is nothing but Ethernet. You can take example of an Ethernet here. So here the internet protocol provides protocols for both the functions of signaling and routing required to carry the entire signal operation necessary to transmit and receive from optical nodes here. And also the signaling protocols include multi-protocol label switching, that will be called as an MPLS, multi-protocol label switching, and also generalized mode, that is multi-protocol label switching, GMPLS, that will be abbreviated as generalized multi-protocol label switching. While the routing protocols include the open shortest path first, that is OSPF. OSPF will be abbreviated as an open shortest path first here. So and also the intermediate system to intermediate system, that is IS/IS will be considered as an intermediate system to intermediate system, and the border gateway protocol, BGP. This will all come under the internet protocol. And if you consider with respect to generic stages, normally internet protocol with respect to optical networks will be having a 3 generic stages. The first generation used the ATM to carry the IP packets. That is internet protocol, that is over the ATM will be considered as a first generation. Here it will be proved that is not only be an efficient technique as compared with respect to direct use of the communication protocol with respect to optical network, that is SDH or SONET. This is because the overhead requirements of the ATM cell structures together with inherent overlap of the IP packets, which may significantly outside the ATM cell size here. Normally the ATM that will be having some different implementation scheme over the IP, that will be depending upon the WDM or DWDM technologies. So here therefore the service providers are considering running the internet protocol content directly over the SONET. So in order to carry internet protocol packets, however, mapping of this particular IP packets directly to the SDH or a SONET frame is required, and the resultant technique is referred to as an packet over SONET, that is POS, packet over SONET. So here this mapping of the IP frames can be accomplished with respect to 3 stages. The first stage will be considered as an the data is segmented into an IP packets, which are then encapsulated via the point-to-point protocol. PPP will be considered as a point-to-point protocol, and the framing information is then added in the second stage, and then finally in the third stage the resultant data is mapped synchronously onto the SDHRS SONET frame here. And if you consider with respect to the second stage, that will be considered as with respect to the three-tier comparising with respect to the internet protocol. It will be having a thin layer of the SONET and a dense with respect to the WDM technologies. So here you can go with respect to opting whether you can be restricting yourself with respect to wavelength division multiplexing, or you can also go with respect to the DWDM technologies here. So this completes the internet